Well, my presentation is about zero emission buildings and the evolution towards the EPBD. My background is, well, you can read on your leisure later, but I was involved in developing the energy performance standards from the beginning when the first, you could say the first EPBD was there and the first mandate was there. This third revision of the EPBD means that we have to make a step forward, as André already explained. The history is that the first mandate we received was in 2004 with the first EPBD. Then we developed the standards in the different technical committees in the more leisure way. And then the recast of this version of the EPBD later on led to a second mandate 480. And on basis of that mandate 480, CEN developed a really coherent set of EPBD standards. As we know now, the standards that have been published in 2017 and only one in 2018. If you, of course, you know the revised EPBD. Here is the link to the revised EPBD. What is the set of standards? I always give this picture just to make you aware of the complexity, but also the simplicity. So you have a set of standards that is describing the you could say the input values and the boundary conditions. Then you have the assessment procedure of the building and of the systems, the different systems, cooling, ventilating, heating, domestic hot water and lighting, taking into account the controls. Then you calculate according to the overarching standard the primary energy, and then you have the post-processing where the standard EN ISO 52003 plays an important role to describe how it should be looked at the energy label and the energy certificate of the building. Now, I don't see. Okay, yeah. So the history is that after the EPBD that was published in 2010, there were some other development, cost optimal calculations, and more guidance to ease the process towards nearly zero energy performance of buildings, and also introducing the cost optimality procedure by could say a guideline and regulation from the Commission, and that leads to a revised EPBD that was published in 2018, where there was more emphasis on cost optimality and NZAP and long-term strategies and smart readiness. But given the decarbonization and the wish to move forward, the Commission decided that this 2080 version should be updated again, and that led to the early revision draft in 2021 that will be published now in spring this year. Well, I don't have to explain this. This is just a summary of your project, but it gives me a good starting point to say a few words on the EPBD standards. The focus is on the energy performance certificate. As I said, in 2010, there were already policy steps towards NZEP and cost optimality. And that was also included in the 2017 standards we have been published. And one of the standards is a standard on the energy performance certificate. That is 50/2003-1. And the scope is to set the EPB assessment standards. The set of EPB standards produces a great number of overall partial indicators as outputs, and this standard provides a general insight to both private party and public regulators and all stakeholders involved in this process on how to make use of the outputs of the different for the different purposes. So it is a post-processing part. The scope is it describes the relations between the EPB indicators and the requirements and the ratings, and it discusses the importance of the project-specific and tailored values as requirement or reference for certain indicators. It also provides standardized tables for reporting in a transparent manner, but the tables are not restrictive, so it gives you the flexibility on member state level how to make the energy label finally. But with the hope that the standards is supporting the harmonization of the energy certificate throughout Europe. We have to be aware that an energy certificated building requires not only to report the certificate as such, but also the related input data. And I give here on this slide a list of input data that should be respected and also put in the database that is available in connection to the energy label. So you need general data on the type of object, on the building category, on the type of application, why the energy label is produced, and for building permit, for energy audit, for inspection. The type of assessment, is it calculated, is it measured, and what climate is respected, the outdoor climate and the indoor climate, and details on the assessment tailored for an individual project. You have to report on ventilation, on the overall energy performance, and on the reference size of the object. And if you talk about the assessed project, the building of part of the building or the portfolio of buildings is the object, and you have to be aware that the assessed project comprises of all spaces and technical systems. You have to describe this in detail in the database. There are many definitions in 50/2003. I just show them here. You have to give on the building, as I said before, a clear information about the category, the building elements, the reference floor area, the reference size of the building, because the square meters are an important parameter in the energy performance declaration. The space categories, because that is generally very important if you look at the indoor environmental conditions, which have, of course, an impact on the energy use. The thermal envelope area, and of course, the indoor and outdoor conditions. And then regarding to the energy performance, you have to state, is it as built, is it measured, is it calculated, is design value, is it a rating on a requirement or is it a certificate? Are there measured energy values? Is it a numerical indicator of primary energy use? Is the primary energy use per reference floor area, and which is the reference floor area? And is it do you talk about standard EP or tailored? Some of the changes in the EPBD that was published in 2010, also and later in 2018, were influenced by delegated acts, and that will be again the case after the publication of the third version of the EPBD this year. So the following slides, I will say some expectations. It is, as we know, the EPBD is developed because of the Green Deal and other policy papers from the Commission. And we have to optimize the building and the system. Energy efficiency first is still the starting point. Decarbonization of the energy carrier and the production of on-site renewables and the focus on zero energy buildings moves to zero carbon buildings. And this is something Laurent Socal will later on give more details on. And the interaction with the energy grid on, is it on hourly basis, is storage taken into account, and how does the Smart Readiness Indicator plays a role in this. And finally, this step slowly during the coming years from towards zero buildings, zero carbon buildings. And finally, we have to address the embodied carbon as well in the near future. The main new outcome is zero emission buildings, deep renovation program. So the energy certificate should also indicate how major renovations are expected in the near future, and how will it impact the energy performance of the building. We also have to address the minimum energy performance standards that has to be set on member state level. We hope by this approach to get that member states will use a harmonized EPC scale. Hourly calculations are mentioned, but not an obligation. But we see from our side of standard developers that it is essential if we want to decarbonize the buildings. And you could say zero emission buildings has to non-residential zero emission buildings has to be equipped by control devices to regulate the indoor air quality. Inspections is an issue, and also it is you could say that the certificate, the energy label, is also an important instrument to realize the national building renovation plans. These are, you could say, the requirements in the EPBD on the maps and the zero emission buildings. And here the zero emission building definition is given. Laurent will give more information on that. The same in Article 9 on how the operational thresholds should be considered. Zero emission building shall offer the capacity to react on external signal, so grid interaction, and adapt its energy use, and generation of storage should play a role where economically and technical feasible. So that that may also have an impact on the energy label and the Smart Readiness Indicator. It is possible to calculate the energy performance value based on total primary energy from delivered energy to the building site, resulting in the same calculation for both non-renewable total primary and operational CO2. But there are different factors, and if you read EPBD, we have a challenge, and we have to, in the coming period, to look at our standards, especially in the overarching standard, how to make the definitions more precise to come to a correct interpretation of the EPBD. Grid interaction, I already mentioned it. It is very important to see how we can also include that in the information in the energy label, because it will have impact on the outcome of your assessment. So it will make a difference if you really can apply grid interaction for your building or not. We will see how this has to be worked out in detail. Thank you for your attention, and what I understood that questions will be asked at the end of the session. Thank you very much.
So good morning, everybody. Jana Bendžalová speaking, and I will try to start my presentation. Do you see it, please?
Yes, we see it.
Yes, it's okay. So in my presentation, I will focus on evolution of energy performance certificates, and I would like to see that how it developed to more harmonized and multi-purpose approach. So my background is national implementation of EPBD since very beginning of EPBD, and I was participating in concerted actions, and this is where I started to cooperate with CEN standards writers, because I was delegated by concerted action to represent concerted action during the standard development. So member states had occasion to influence a bit the standards development. So my focus will be on EPC. So there was development, already mentioned different versions of directive on energy performance of buildings. So in the first versions there was introduced energy performance certificate, but there were totally diverse national approaches. There was no definition of primary energy as energy performance indicators. Only harmonization was that aspects to be considered were listed in the annex. Then there was very important new EPBD in 2010, EPBD recast, and this directive already introduced primary energy as indicator for definition of nearly zero energy buildings. So it was some steps to harmonization. Then it introduced cost optimal levels calculation, and there was also attempt by Commission to come to some harmonization, because, for example, also energy calculation was described in regulation and guidance document, even if it was not fully in line with EPB standard. I think very important for evolution of energy performance certificate is Article 11.9, which was introduced by market player, by big international owners who had hotels in several hotels or other office buildings in around Europe, and they needed some comparable certificates. So this article says that the Commission shall, by 2011, in consultation with the relevant sectors, adopt a voluntary common European Union certification scheme for the energy performance of non-residential buildings. So even if this was not never implemented, I think it had a huge impact, because there were two studies for DGNR in 2010-2011 study EPBD Voluntary Common European Certification Scheme. And for example, in this study has been proposed common European scale that is now also in European standard, and many technical developments. And in the final stakeholders meeting, it was decided, because it was obligation for Commission to issue it until 2011, and it was decided that common calculation method is needed, and it was postponed until EPBD standards are ready. So in 2010, mandate for new EPBD standard development was given by Commission to CEN. And in 2016-17, it seems that calculation tool is here, and there was a next study enabling the European Common Voluntary Certification Scheme for non-residential buildings, and it was about technical, operational, and organizational design development. So there were many development, also including voluntary certification schemes like BREEAM, DGNB, and so on. And this was for support the preparation of an implementing act, and Commission also made proposal for this act, but it was refused by member states in EDMC meeting. So, but the work in these studies is not lost, because this work was idea to propose Aldren project, because some consortium partners were involved in both the studies for Commission. And I think also that this work is not lost, because a lot of these proposals is now in EPBD revision. So then there was an important amendment of directive, where was, for example, long-term renovation strategies were moved from energy efficiency directive to energy performance directive. It was introduced electromobility, obligatory building automation control systems for big buildings, and there was also introduce more transparency and harmonization and more informations to be included in EPCs. And for example, it is reference to overarching standards and mandatory development of Annex A by member states to these standards to describe their national calculation methodologies, and it was Smart Readiness Indicators, building renovation passport, and a proposal to be used EPCs for the financial measures by issuing EPC before and after renovation. So this article 11.9 about European Voluntary Certification Scheme is still in current EPBD, but it is removed from the revised EPBD that will be perhaps issued in 2024. But it is very logical move towards harmonization of mandatory schemes, because these aspects and developments are said from the studies and from Aldren projects are introduced. So there will be our obligation to implement new directives that I believe is more transparent and harmonized and provides comparable results around Europe. So I will say now about two projects. It is Aldren and EPC Recast, which developed several tools that could be perhaps interesting for a Smart EPC project, because I understand that it will also make link to existing tools and development. So Aldren, as I said, it was based on voluntary certification scheme, the idea. So 8 European partners worked on this project. And the aim was to provide transparent, consistent, common European-wide assessment framework to trigger more ambitious renovation and support for common language, EPBD articles implementation, and provide some technical tools and methodologies for implementation of these articles. And so it provides some improved metrics, decision support protocols and tools. And what was a very important part of ALDREN was that there was an ALDREN Alliance, which was a group of stakeholders, because we tried to find some common language between energy performance and different market actors like financing, institutions, asset valuations, comfort and indoor air quality. So there are four main modules or tools in ALDREN. So for the simulation, energy performance, European energy rating, renovation objectives, then it is addressing gap between calculated and actual energy performance. On this part was working Verco from UK, who has very big success with this methodology in UK. Then it was evaluating indoor environmental quality, health and well-being. On this part was working Danish Technical University and CSTB, and they also provided very high quality tools and methodologies for indoor air quality assessment. And the last one, very interesting, was linking all these modules with so it means energy with health and comfort to financial valuation. So we really evaluated the market value before renovation and after renovation. So we counted externalities from improve energy performance and comfort and transfer to market value of buildings. And the main outcomes from these modules are energy performance certificate and building renovation passport. So we focus on certificate today because it could be separate presentation about each of these modules. So about the certificate, so in ALDREN already were all indicators that are now proposed in revised EPBD. So there was main indicator, it was non-renewable primary energy at the time, but it contained all indicators that could be useful for somebody, for some institution, for example, for building, for European green taxonomy and so on. So it included also total primary energy, energy needs, final energy, thermal comfort. It also included measured energy corrected to standard climate and use. And we had several meetings with existing voluntary certification schemes and also with levels to really provide all indicators that could be used by them, and not only one main indicator that could be decision by member states that energy class will be based on it, but it should provide also other information. Then we also propose for requirements for ALDREN nearly zero energy buildings that is based on harder arrays, so it means that it's not one indicator, one energy class, but 4 requirements. About the main features of calculation methodology for this European voluntary certificate, so it should be based on EPB standards. Hourly calculation step is mandatory. There is a common scale, which is now option 2 in European standards that Jaap mentioned. And we also calculated several reference buildings to estimate values for 3 climates. So we made hourly simulations and defined scale for 3 climates. And what is important, we propose that calculations should be for climate of building location, and we recommend to use John Research Center typical meteorological year This is very important if we want to make some financial valuations or cost optimality or link the certificate to actual energy, so give information to owner. And as an example, on the right side, you can see number of inhabitants in climate localities in Slovakia. So on the x-axis, you have number of heating degree days, and you see that national climate for EPC represents this part of inhabitants. So inhabitants is equal to number of buildings approximately. So I'm not sure that we can talk about some link with financial valuations and cost optimality. We use only the standard national climate. I think this is also a situation in more member states. So Aldren has a modular structure. So there are two obligatory first pages which fulfill EPBD, and then there are voluntary pages that can be issued or not, depending on the purpose of certificate, and they can be also taken over by member states, so they do not need to change the official certificate, but for example, for some purposes, they can say that they want also, I don't know, SRI, which you can see here in front because you are probably interested. And these additional pages include indoor air quality, SRI, financial valuation, risk assessment, and measure energy as a separate reporting page. And you can find more about all these modules also in Rehva journal, because there was a special issue about Aldren, and I think all these tools are quite well described in this journal. So the next project I would like to promote here is EPC Recast. So here you can see a consortium, very strong consortium, very important partners. And the aim is to provide some cloud system toolbox in which the key components are energy performance assessment, inputs, so improve data collection, quality procedures, and reliable calculation methods. So there is a consistency check, data cross-checking during calculations, and it is comparison with measured energy consumption. It is energy performance model calibration or verification of calculation. And there is also a very important tool, a renovation roadmap. So Aldren was focused on hotels and office buildings, and EPC Recast is focused on residential buildings, and it is focused not only on owners, but also on assessors. So we try to help assessors to collect data and to evaluate building. So in this cloud system toolbox, you can find, for example, a link to tool for scanning the geometry of the building and so on. I must say that not all tools are free, because this is innovation action and some of them are commercial. And what is very interesting in EPC Recast is that there is also long-term monitoring of several pilot buildings. So we will have really a huge amount of data to compare calculated energy and really measured energy. So you can also find more in this website about EPC Recast. So about the EPC template in EPC Recast, so we recommend Aldren modular design for professionals, but we also developed owner-tenant EPC, so that we try to provide information that is obligation in EPBD, including the last version. So it is a template in line with the new EPBD. And we try to motivate owner to renovations. So it is split to left side, which is current state, and after renovation, it is on the right side. And important is that we report all options for key performance indicators for different purposes, so that it fits also to European taxonomy, because you perhaps know that what is the main problem for banks implementing taxonomy is that they have to report energy savings and portfolio performance in total primary energy, but many member states have only non-renewable primary energy as indicator, including Slovakia. So in these EPC, they should find all indicators. So there is also thermal core from global warming potential. In grant agreement, we had to provide also complementary vision for tenant and the owner, different views. So there is part about costs. So global costs are more for owner, and operational costs are more for tenant. So there is also reported Smart Readiness Indicator, but only the result, because we have in the consortium also Liz, who is expert for Smart Readiness Indicators. They provided us training, and we recommend to use official tool, but then report in EPC. And there is possible, it is in Excel, automatic translation. I apologize, because when I made print screen, I see that I took Slovak, because it's easy to switch. So in the final version, I will put English version of EPC. So what is very important, and what I think should be always in each national EPC, is that there should be some annex where all the choices for calculation of performance indicators should be clear. It is needed not only for transparency and comparability for Commission or for banks, but it is also for understanding by owner, because he should know what is included, if exported PV is counted or not, if ambient heat from heat pump is counted or not, because I cannot imagine how he can use some value without knowing all this. So we propose it is Excel table where are pre-selected answers, because they should be in line with 10 standards options and with options that are used at national level. So the last slide is about the EPC in new EPBD. So it's clearly more harmonized and multi-purpose. So it has link of EPC to policy instruments like minimum energy performance standard, nearly zero energy building, zero emission building. It is also mentioned in National Building Renovation Plan, financial measures and databases. So databases of EPCs will be obligatory. It is not today, and they will have to be uploaded data to European Building Stock Observatory. Also input data for calculations that I think is possible only if we have common software. So very good for harmonization is that Commission will provide the template for this data structure and so on. Then there is a link to European Green Taxonomy. It is written in EPBD that taxonomy needs EPCs, and this is why there is this common template and scales, because taxonomy refers to class A, but in some countries class A means class C, because there are class A plus, A0, and so on. So harmonization and greater comparability, more indicators is clear because there is reference to 10 standards. Calculation has to be in annex, described in annexes A. And as I say, important is that Commission will provide common templates and delegated acts for many of these instruments. So more information, there will be obligatory SRI for non-residential buildings over some size. There will be global warming potential, building renovation path for indoor air quality. And this version of EPBD goes a bit more deeper also about meter energy. It says that it can be used for calculating the energy performance, but it must be normalized. That influence of user should not be included, and also not of the climate during measurement. And it can be also used for verification, and there is also set minimum step for measurement, monthly step. So all this we will have to implement, so I will not talk more about, because each topic could go in much more detail. So thank you for now, and I will give floor to Laurent.
Thank you, Jana. So good afternoon, really good afternoon to everybody. I think you should see my presentation now, and we will go through my background. You will be able to read it afterwards. I also have an experience as an installer, designer, and also in practice. And in summary, my presentation will be about the indicators. You need indicators in the EPC, and it is important that we analyze this in details and the consequences and the relationship with the requirements of decarbonization. So the interaction, we will analyze the interaction of the building, which is through delivered and exported energy. So we need weighted energy to express indicators, and have a look at what does decarbonization mean in practice, and the emerging concerns, energy storage and demand flexibility, and their relationship with indicators and consequences on calculation methods. So this is what we will do now. So just in short, to remember, the calculation starts from the energy needs, which is the energy which is dependent on the building envelope and of the use of the building. And this is our starting point, to energy to be supplied or extracted to provide a building service. You have just an example for heating and cooling, and then a technical system has to supply the needs, and they use electricity, fuel, in general, energy carriers, which are supplied through the assessment boundary. This is what we call delivered energy, which in principle is something that can be also metered. And but what is the real effect on the environment? It is not what happens here. We can calculate up to the assessment boundary, but what is important for the environment is resource depletion, pollution, greenhouse gas emission, economic costs. So what happens outside the building? This is the question, and this is taken into account by the so-called weighting factors. And here you have an example, very simple, about primary energy. For example, 1 kilowatt-hour gas, well, we have to take something more from a non-renewable source. And this is just non-renewable energy, because we need pumping and we lose some gas on the long road from the well to the building. For electricity, it's a little bit more complex, because you have both a non-renewable content and a renewable energy content. So you will need two factors, and this will be strongly dependent on how you produce electricity. And this is depend, of course, on what happens in your nation, in your state. This is a very simple example. So what is the effect on the surrounding environment? We start from the assessment boundary, and we have to weight the energy carriers and to according to specific cost, a CO2 emission factor, and or a non-renewable primary factor, or renewable or total primary energy factor. It depends on your concern. By the way, since the concern of the EPBD is shifting from resources depletion, which means renewable energy, not to exhaust our energy. 2, emissions. We define now a zero emission building. Also, the metrics should shift to basically the CO2 emission factor. And you see this is sneaking in the last version of the draft EPBD. So that's very important in the energy terminology to distinguish the needs at the level of building, usable energy within the building, delivered or exported energy, and different energy carriers cannot be summed as is in kilowatt hour. You have to list them separately. If you want to sum apples and pears, you have to use a common property of apples and pears, such as a weight, as a price, or anything else. So that's why then we speak about weighted energy, which is a common property of all energy carrier, so that we can sum them and have one indicator. And here you have a summary of the main weighting factors. So primary energy, and that's something that should be very clear. Saying primary energy is not a fully defined concept. You have to add whether you are interested into non-renewable, renewable, and total, because this has a different meaning. So primary energy alone is not enough. Otherwise you have mainly the ambiguity between non-renewable and total primary energy. This is a main doubt you might have in reading regulatory documents if this is not specified. But then you have also CO2 emission costs, and these weighting factors. There are also standards to justify this, also introduced in the new recast EPBD draft. Well, it is, well, let's have a look at the CO2, for example, which is also interesting. In case of the CO2, 2 things might happen, because when you are weighting the CO2 emission of gas or a fuel, it's mainly on-site emission due to the combustion process, and something, of course, along the road. On the contrary, if it is a CO2 emission of grid electricity, there is nothing emitted on site, but of course you have CO2 emission right at the production of electricity. So using electricity, you only have off-site emission. I say off-site to mean anything else than on-site. And that's important, this difference between on-site and off-site, because in the latest available definition in the compromise text that was available in December, we are slowly shifting from a zero emission building to a nearly zero emission building. Because if you look at the definition, a building with a very high performance, which requires zero very low amount of energy, zero on-site carbon emission from fossil fuels. And here you have some emission which is sneaking in, because if you use a non-fossil fuel like biomass, then you might have some CO2 emission during the processing of this fuel. And producing zero or very low amount of operational greenhouse gas emissions. Okay, that's a CO2 emission embedded into the delivered energy carriers, because it's nearly impossible to run a building just with local resources, just like off-grid. So you need to have some amount. And here you can see that really you should say it's a nearly zero emission building, because a little CO2 emission is still allowed, with conditions, but still allowed. Well, until we speak about just delivered energy, everything is quite simple. Delivered electricity from the grid, okay, that's clear. We are using 2.5 kilowatt hours non-renewable for each kilowatt hour delivered. And if we shift to just a PV, it's clear again. It's 1 kilowatt hour renewable in that case, which is feeding our building. So it's very clear. I'm running on renewable sources. Perfect. Through the assessment boundary. But what happens if I turn the lamp off and my PV is still producing? I will export this energy. And now you have a fundamental decision to take. How do you evaluate this kilowatt hour of exported energy? Are you exporting 1 kilowatt hour of renewable energy? Or are you saving the use of 2.5 kilowatt hours by the grid generator? Both options are valid, but you have to select one in making your calculation. And this is a fundamental choice which have deep consequences and is indicated into the EN ISO 52000-1 by a parameter which is K exported. Oh, well, in short, you could say for exported energy, if you use K exported equals 0, then the exported energy is not part of the energy performance of your building. If you choose 1, you are embedding this exported energy into the energy performance. And this choice is a game changer. For full details, please go to these supporting videos on the EPB Center website. But it is very important that just with a simple example, we look, because we want to deal with demand flexibility, but it's already difficult to deal with exported energy currently. So first we have to be very clear about this. And this is summarizes how I explain this, including or excluding exported energy from the energy performance, but you have consequences of K exported equal 1. Because you have if you select K exported equal 1, you will have cross compensation between energy carriers. You can compensate non-renewable uses by renewable generation, and you compensate between electricity and electric energy produced and used at different time. In fact, you are completely obscuring the fact that you might use storage, and because you assume that the grid is a perfect battery. So this is not consistent with having to identify the importance of demand flexibility, as we will see later. And just to illustrate this, this is an example. If you exclude the exported energy, you have here a nice building, very effective, as it looks like, with a very old boiler, and just put on this building some PV. So if you need 15 megawatt-hour gas and you have enough PV, you might cancel out as a balance. But with K exported equals 0, this is not allowed. This is still a building using gas. And if you use K exported equal 1, in that case, you can cancel out, and this looks like a nearly zero energy building. So here you have an example why just this single parameter is a game changer. So the result before it was 16 megawatt hours primary, and here in this case it is 1. And this is true both for non-renewable and for total primary energy, this kind of effect. Well, so here you have just a summary of what I told, so I will skip this slide. You will just be able to read on this slide what I just told you on the figures. And now let's come to what's new in EPBD recast. So the new general goal is to decarbonize. Okay, so therefore it's zero local emission of new buildings within 2030 and zero emission of existing building within 2050, which is quite near. And the focus on life cycle assessment. So it means first the concern was energy, nearly zero energy building, and now it's CO2 emission and full life cycle. So we should change the metrics, as I told you before. But let's go into, and of course, we will not speak about maps, which is probably the most disrupting consequence for the economics. But let's go on and let's have a look at what does decarbonization mean. If we speak about energy sources, the current situation is that we have natural gas, oil, coal, and then other sources. And what we should always remember is the availability of sources. That is a fact that we can get from that source the energy when it is required. And so for these sources, so availability is high. My well is always available, and here too. But for thermal solar photovoltaic, for example, and wind power, the availability is low because we don't know when, or probably we know when probably we might have some PV during summer, during the day, if no cloud is obscuring the sun. So it is, and that's a very important property which shall not be forgotten. And these are some of the properties of these sources. And if we want to decarbonize, this means that the first three are dismissed. And this is not the topic today, but just imagine to have to cover buildings, transport and industry with these remaining sources. It's a big challenge. This is a global concern. But in practice, this also has another consequence for our building, because this applies also to energy carriers, because our building is connected by energy carriers. So the current situation, these are the energy carriers which are available today. In bold, the most important, because this biogas and biodiesel, this is limited in quantity available. So here you have other properties, and here you have some notes. And I mentioned also hydrogen and synthesis fuel, because this is now experimental, so this could have an important role in the future. So here you have some properties, the possibility of the storage, local storage, and grid electricity. No on-site emission, but the environmental impact depends on how it is produced. And the storage is very expensive and limited. This is one limit of electricity currently. And if we want to decarbonize, and this is a consequence for our buildings, these energy carriers are no more available. So we have to rely on grid electricity plus something biogas, biodiesel. Probably somebody could add also district heating and cooling, but okay, so just pushing a little bit just pushing the question a little bit aside, and probably hydrogen and synthesis fuel in the future. But the main, of course, is grid electricity. But this has a consequence. If you move everything on grid, we need to double the capacity of network and generators. Otherwise, we will have troubles if we are adding everything on electricity, because if you delete these carriers, these were the main carriers for transports and for half the industry, if not more. So everything on the grid, you have to multiply its capacity. And this is a long road, because you can see this is a very interesting app, and you can see nowadays which is the current carbon intensity of electricity in the European countries. Actually, this app covers the entire world, so you can have an idea of the global situation. And of course, if we want to run on electricity, we have to find the sources, but we have also to reduce energy use. Otherwise, the grid will have issues. That's why it's important that we reduce also the energy use in total. And the grid itself is an instantaneous equilibrium of use and generation. There is no storage capacity in the grid. So that's why there is a help needed, which is demand flexibility. And that's the reason why we have demand flexibility, because the sources that we will have to use are not available. So we have to do something to ask for energy at the right time. Otherwise, it doesn't work. And here you can see if you put another weight on this, what can happen. That's very interesting to have a look here. So the local decarbonization challenge is now to shift to electric heating heat pumps. And I already mentioned the reduction of energy demand and peak power, that means insulating buildings, and local production of energy, which will be mostly PV, but it's limited by the available area, the building footprint, and you have to contribute to grid stability. Well, the smart grid, it will not be so smart for the building, because you will get two signals. Don't use energy from the grid, or use energy from the grid, depending on availability. In other words, to do this, you have to store energy into your building. That's why, in turn, it is very important we have a look at what happens. And here is another example of the importance of availability and the meaning of K exported. This is a trivial example where you have a production in one day, which is 18 kilowatt hours, and you need 18 kilowatt hours for your building. But this is a profile during the day. And you will see that, of course, PV will come during the day, whilst you need still some electricity also during the night. Even if you are full electric, here you are loading probably your storage for domestic hot water. Here you need also to something to run your fridge there or other things. And so you need electricity indeed. So if you do an evaluation, and here you have two different approaches to evaluate the degree of the contribution of the PV. You can say that you can say that you have a coverage of 31%. It means that you had the PV at the right moment, the green part. And then you have also this excess PV that may compensate the required electricity during the night. This is compensation. So you could say here we have 100% compensation and 31% coverage. When you are calculating with K exported equals 0, you are calculating the coverage. If you calculate with K exported equal 1, you are calculating the compensated value. So you can see here, and to increase coverage, which obviously is the objective, because here you rely on the grid, and in turn the grid relies to something else. You may alternatively either move energy use over time. So you could, for example, tell your storage, please reload during the day, store electricity on a battery, or store heat in the building and or in the system. So you can use this to improve your diagram. And okay, if you use, of course, the logical choice for the zero emission building in that case is K exported equals 0, because if you use K exported equal 1, the grid is assumed to be an ideal and unlimited battery, and you hide the real burden for the grid. And the effect of on-site storage in the evaluation and of the electric system efficiency will be completely obscured in the main indicator. So that's why I think that the correct choice for this coefficient is K exported equals 0 in this new context. And here you know probably this picture. It means that we will have to evaluate. This will be part of the new EPC, the evaluation of the electric system efficiency. And of course, this is a lot about using the local storage. And if you use K exported equal 1, the storage management has no impact on the main indicators. So that's another reason why the choice could be K exported equal 0. And just to have a flavor, maybe I will not go through all the details, but here I made some simple calculation to show the possibility of the different types of storage. You might store heat. Here, so heat capacity, specific heat is your parameter. And here you have an evaluation and what you can accumulate, because you need not only a capacity, you need also an acceptable temperature difference. So here you have an example for a storage of water, for storage heat in the structures, and the result is always the same. Only daily storage possible. This is a possibility with sensible heat storage. I will skip latent heat storage, which is not really interesting. It's just for special cases. And other electricity storage, here you have another important concept. If you compare electricity storage by batteries and chemical storage, currently there is no match. Just an example for cars, for example, this is power which is actually available when you reload the battery. With electricity, you are about 100 kilowatts, but when you are filling your tank at the gas station is 21 megawatts, the power at which you refill. So here, really no match. And also the cost of the battery. Here you have the comparison of two equivalent things. This is a battery for a Tesla, 75 kilowatt hours. This is the price, and this is the equivalent in chemical. And this is to show that only chemistry can provide a seasonal storage. And that's an interesting property of synthetic fuels. So that's why you might go through chemistry, and you might still have a requirement to have synthetic fuels just to overcome the problem of seasonal storage. Otherwise, it's quite difficult. Now, challenges for calculation methods. So, of course, you need, the last recast still opens to monthly calculation method. I think there is no story. If you want to incorporate demand flexibility, dynamic weighting factors, complex control options, discomfort, there's no possibility to do this with monthly methods. So it shall be hourly methods. And of course, we have to introduce the energy storage. And so it means adding this in 52000-1. That's quite simple. Thermal storage is already foreseen in these other standards. And of course, even in 52016, because you can take into account the effect of overheating your building to store energy. And I think we have to set this default. Otherwise, you are masking all interaction with the grid. And also some completion, especially on the structure of the calculation, and to deal with operation possible. And the operating condition of calculation of technical system has to be also extended to cover the operation modes required by demand flexibility, because in that case, you cannot assume just an average operation mode. You need to recover after not being allowed to use energy from some time because of the smart grid, and explicit inclusion of automation and control algorithms, because this is to be taken into account to evaluate the behavior of the whole system. And that's also consequences, of course, that's very special on heat pump calculation methods. And conclusion, so we have gone through some decarbonization issues. And the first will be providing a mix of energy sources that is able to cover buildings, industry, and transport energy demand when needed. And that's the point. And providing seasonal energy storage. PV without seasonal energy storage, no chance to contribute significantly to the total the need is at the right time. Increasing the electricity grid distribution generation capacity, because or providing a mass production of synthetic green fuels. Otherwise, you cannot transport the energy to your customers, and reducing building energy use in terms of energy and power. So demand. So it means insulation, heat recovery, energy efficiency, which is also helpful to use heat pumps as well. And designing, installing, and commissioning complex technical systems, much more complex than what we were used in the past, and adapting calculation method and regulations. In my opinion, this will be very interesting technically, but neither easy nor for free. It will cost something. Well, maybe it's worth paying the cost, but it has to be paid. Otherwise, you can't do all these things just for free. I think this is all. Thank you for the attention, and I think we can have a short a short demand session to all the